Okay, this is a quick video about rationalizing a denominator, and this is from section 10.3. So we've discussed enough already that we know that we cannot leave a radical in a denominator. And if the radical is just a monomial, we would just multiply the top and the bottom by that radical monomial, and we would get rid of the radical that way. However, this is what we do if the denominator is not a monomial, but a binomial. So if you see here in our example, we have 10 over radical 7 minus radical 2. Now, I can't have a radical in the denominator, and I can't simplify it or combine it, so I'm going to have to fix it somehow. And what I want you to do is think difference of squares. And if you look at our example here, this x plus 3 times x minus 3, this is our reminder that when we multiply two binomials that are the exact same except for the operation in the middle, so one plus and one minus, that negative 3x and that positive 3x, they drop out. And we're just left with the first value times the first value and the last value times the last value. That was our difference of squares from chapter 8. Well, we can use that same idea to get rid of this radical 7 minus radical 2 in our denominator here. So we're going to multiply by 1, which is always our only choice. Whenever we have an expression, we're not allowed to change the value. So if we have to rewrite it in some way or another, whether we're simplifying a fraction or getting a common denominator or getting rid of a radical, all we're really allowed to do is multiply or divide it by 1. But what's nice is we can make that 1 look like whatever we want. And in this case, we want it to look like the exact same binomial, radical 7 and radical 2, but instead of minus, like our original expression has, we're going to use plus. And why we do that is when we multiply radical 7 times radical 7, we get 7. Remember, anytime we square a radical, they undo each other. So we're just left with the radicand, what's inside. So we have 7. Then we have radical 7 times radical 2 gives us radical 14. Then we have negative radical 2 times radical 7, which gives us negative radical 14. Then we have negative radical 2 times radical 2, which gives us negative 2. So what ends up happening in our denominator is we just have the positive radical 14 and the negative radical 14 cancel out. We have 7 minus 2. So our denominator is going to be 5. And that solved our problem getting rid of the radical. What we see on top is we are going to have to multiply this radical 7 plus radical 2 times the 10 that was in our original expression. And my suggestion to you is that we do not distribute right away. So I'm just going to rewrite this as 10 times radical 7 plus radical 2. And I'm going to leave it that way. And here's why. Once I rationalize my denominator, look what ends up happening. I end up with 10 times radical 7 plus radical 2 all over 5. Well, I can reduce that 10 and that 5, right? I can say 5 goes into 5 once, 5 goes into 10 twice. Then I'm left with just 2 on the outside, radical 7 plus radical 2, and a 1 on the bottom, so my denominator is basically gone. And now I just have 2 radical 7 plus 2 radical 2. That's my final answer. So just a reminder, kind of in summary, whenever you have a binomial in the denominator of a fraction and there's a radical involved, you're going to multiply it by that exact same binomial with the opposite operation. So if my original one is minus, the one I'm going to multiply is going to be plus, and vice versa. Then that's going to make the radical or radicals, whether there's 1 or 2 on the denominator, doesn't matter, they're going to drop out. And I'm going to be left with just an integer for my denominator. Okay? And I can sometimes reduce that denominator, sometimes I can't. Here's another example. I had 7 over radical 5 plus radical 13. So I multiplied it by radical 5 minus radical 13 over radical 5 minus radical 13. And when I double distributed that denominator, I ended up with 5 minus 13, which is negative 8. I can't leave the negative on the denominator, so that had to go up to that negative 7 up in the numerator. And then I distributed the negative 7. So my final answer was negative 7 radical 5 plus 7 radical 13 all over 8. Okay, hope that helps. Your homework tonight, right here, 10 to 54 evens, starts on page 1515. See you tomorrow.